This is the question for a 14-speed gearbox. The question states to construct the kinematic layout and ray diagram for a overlapping speed gearbox with 14 speeds varying from 125 to 1500 rpm. Also find the number of teeth for each gear in the layout. So as I know the formula, n final divided by n initial is equal to 5 divided by z minus 1. I have the value for n final as 1500 and n initial as 125. Keeping z as 14, I get the value for phi as 1.21. Using page 7.20, any combination will not reach a value for phi is equal to 1.21. Whether I multiply the value for phi of 1.12 as 2 times or 3 times, the specified value is not being reached. Therefore, I'll use a different approach over here. I'll take my initial speed of 125 and then start multiplying 1.21 or the value of phi to obtain all the speeds. So I'll be doing this step 13 different times to obtain the 14 speeds which I want, starting from 125 to 1488, which is really close to 1500. A gap of about 10 to 20 plus minus can be taken. Also, I have rounded off all the values I have obtained for the different speeds to the nearest integer. The structural formula for a 14-speed gearbox is also a little different. I'll be taking a 18-speed gearbox structural formula, which is this one. The last part of this structural formula, 2 bracket 9, gives us 18 speeds, but I need a 14-speed gearbox. Therefore, 18 minus 4, that is 14-speed gearbox. So I will be subtracting 4 from 9 to reach the 14 speeds. Finally, my structural formula becomes 3 1, 3 3 and 2 5. If I needed a 16-speed gearbox, I'll be subtracting 2 from 9. Therefore, the formula for a 16-speed gearbox would be 3 1, 3 3 and 2 7. Final diagram will have 4 overlapping speeds. The 4 we subtracted here. We'll get to know about that later on. Starting with the structural formula, the process remains the same. First, I'll look at the structural formula, and on the first stage I have 2 5 or interval 5 and speeds 2. That is, my first speed would be 125 and the second speed would be 324. Taking input that is greater than half of these speeds as 268, both my conditions are getting satisfied. So I'll be joining 268 to 125 and 268 to 324. Stage 2 is 3 3 in the structural formula, or intervals 3 and speeds 3. Therefore, my speeds would be 268, now an interval of 3, that is 474, again an interval of 3, that is 840. Selecting input as 574. 574 satisfies both the conditions. I'll be now joining 574 to 268, 574 to 474 and 574 to 840. This line over here will have 3 speeds with 1 interval each. That is, my first speed would be 574, second would be 694, and finally my third speed would be 840. For the stage 3, I'll take the maximum possible RPM, that is 1488 over here. Now I'll be joining 3 more lines, 1488 to 574, 1488 to 694 and 1488 to 840. After joining the basic lines, I'll try and make all the combinations that are possible. As I see over here, I get 4 overlapping speeds, that are 324, 392, 474 and 574. Finally, my ray diagram looks like this with those 4 overlapping speeds. Coming to the kinematic arrangement, as the structural formula states 3, 1, 3, 3 and 2, 5, my first gear combination would have 3 gears, second would have 3 gears again, and the third gear combination would have 2 gears. To calculate the number of gear teeth in each gear, I have a set of formulas and rules. First thing is to number all the gears. So I've started here with 1, 2, 3, 4, 5, 6, going on till 15 and 16. Now I have to write the respective speeds. So the input speeds for the shafts would be 1488, 574 and 268. The speeds for the bigger gear would be the smaller one, and for the smaller gear would be the bigger one. So my first combination would have speeds 125 and 324 as I took in the first stage while making the ray diagram. Second combination would have 268, 474 and 840. And the third combination would have 574, 694 and 840. Now the next step is assume the value of one gear as z is equal to 20 and calculate the rest. Calculation part I'll show you in the next step. Now I have to assume the value of any one of the gears in the given 3 combinations as 20. I just have to keep in mind only the input shaft has to be chosen as 20. Therefore I can either choose 13 or 15 or 7, 9, 11 or in the last pair 1, 3, 5. After calculation of all the gear tooth, I need to check that the adjacent gears on the same shaft should have at least a difference of 4 between them. The gear tooth should have a difference of 4. If not, we have to multiply all the teeth by the value of 4 so that the minimum difference is created. Now for calculation of gear teeth, I'll be first taking gears 13, 14, 15 and 16. Assuming Z15 is equal to 20, that is on the input shaft, I can write this formula. Z15 by Z16 is equal to N16 by N15. Here N16 is 125 as I had written in the kinematic arrangement. N15 is 268 or the input shaft. Therefore, cross multiplying, my value for Z16 comes out to be 43. Taking the next pair Z13 by Z14 is equal to N14 by N13, I have N14 as 324 and N13 as 268 or the input shaft. Therefore, I can write Z13 in terms of Z14 as 1.20 times Z14. Also, I know that my value for Z13 plus Z14 is equal to Z15 plus Z16, or substituting Z13 in terms of Z14, I get the value for Z14 as 29 because I already know the values for Z15 and Z16 from the above calculation. Therefore, my Z13 now finally comes out to be 34. Now instead of 2 pairs of combinations, I have 3 pairs. So I'll be taking gears number 7, 8, 9, 10, 11, 12. Assuming Z11 as 20 because it is on the input shaft, I can write this formula Z11 by Z12 is equal to N12 by N11. Here N11 is input, that is 574 rpm, and N12 is 268 rpm. Therefore, cross multiplying, my value for Z12 is 43. Coming to the next pair, I know Z9 by Z10 is equal to N10 by N9. N9 being on the input shaft is 574, N10 being 840 as per the kinematic diagram. I can write Z9 in terms of Z10 and substituting in the formula Z9 plus Z10 is equal to Z11 plus Z12, I get the values for Z10 and Z9. Finally, the third pair Z7 by Z8 is equal to N8 by N7. I have N7 is the input, that is 574 rpm again. N8 is 474 rpm. Writing Z7 in terms of Z8 and putting in the formula of Z7 plus Z8 is equal to Z9 plus Z10. Z9 and Z10 are written from the above calculation. I get the values for Z7 and Z8. The last stage is the gear numbers 1, 2, 3, 4, 5, 6. Here I'll be assuming Z5 as 20. I can even assume Z1 as 20 because both of them are lying on the input shaft. I know the formula Z5 by Z6 is equal to N6 by N5. N5 being on the input shaft is 1488 rpm. N6 is 574 rpm. Therefore Z6 turns out to be 52. Also, Z3 by Z4 is equal to N4 by N3. Here again N3 is on the input shaft of 1488 rpm and N4 as per the kinematic diagram is 840 rpm. Writing Z3 in terms of Z4 and putting in the formula, I get the values for Z4 and Z3. The very last step to calculate the number of teeth for 1 and 2 is this: Z1 by Z2 is equal to N2 by N1. N1 is the input, that is 1488 rpm, N2 is 694 rpm. Again, following the same procedure, I get the values for Z1 and Z2. Finally, I am writing down all the values I have obtained from the calculation over here. These are the teeth present on each gear. Stay tuned for the video on 18-speed gearbox. Ask away any questions you have in the comment section. Robometrics.